Hello, Algebra 2. We are starting Chapter 9 today. 9.1 is called Mathematical Patterns. All right, so mathematical patterns. So we're going to learn lots of different ways in which we can form sequences, which is basically just a list of numbers that come from some sort of pattern, a list of numbers where you can see a consistent pattern from term to term. And that's what this chapter is about. It doesn't feel a lot like algebra. It's kind of a chapter in and of its own. So it's really important to get on board with this because these type problems aren't just something you can figure out or do on your own. You kind of have to know the algorithm for solving them. So pay attention. 9.1 and 9.2 will be on a video. Okay, so a definition of a sequence is an ordered list of numbers called terms, okay? And we have two different sequences that we're going to deal with, two of them. One is called explicit, and so 9.1 is just really going through the differences between the explicit formula or a recursive. Recursive, recursive formula. So two different ways, explicit and recursive. So the biggest difference here is this is the formula right here, okay? Find the first four terms in the sequence and then find a20, okay? And then recursive, find the first five terms in the sequence. So notice the explicit just is defined with one equation, but the recursive is defined with two. So that is a huge thing to note as we are starting this. Explicit is defined by one statement, and a recursive is defined by two. Okay, so really the subscript of 20 is just like x equals 20, or for this particular situation, n equals 20. So instead of x, we're using this letter n. All right, and this what it's asked for here is 20. This just means to input 20. So super easy math, just a different look. But first of all, we've got to find the first four terms. So a to the n, this is the general explicit formula. And so we just say a to the first, okay, is 2 times 1. It's just the plug-in, and that's just 2. So that's the first term. Notice this 1 correlates with the term number. So a subscript 2 is the second term. You just plug in 2. 4. Third term, 2 times 3 is 6. And fourth term. So you plug in 4, you get 8, and 8 is the fourth term. 8 is the fourth term. Okay, so if you were to write the first four terms in a sequence, notice it's an ordered list of numbers. So this sequence here would be, if the first four terms we would list as 2, comma, 4, comma, 6, comma, 8. Okay, so that's the first term, n equals to 1 plugged into the formula, n equals 2 plugged into the formula, n equals 3 plugged into the formula, n equals 4 plugged into the formula, dot, dot, dot. And then it does say to find the 20th term. So the 20th term in this sequence would be 40. Pretty easy stuff as long as you know what's being asked of you. Okay, and so same thing here. First term, just plug in for n1. Okay, so that is going to be -5. -7 times 2 plus 2, that's -14 plus 2, so -12. Third term, found by plugging in 3, that's -21 plus 2, that's -19. And fourth term, just following directions. Why am I doing the first four terms? Because the directions told me to. Okay, so if you were to have to list these out, you would say -5, -12, -19, -26. And if you were to continue, you say dot, dot, dot. If you ask for just the first four, you would just list the first four. But that is a sequence, Okay, that's a sequence, and that's an explicit sequence. Now, a to the 20th will just be negative 7 20. Why am I doing that? Because the problem told me to. Negative 7 times 20, which is negative 140, plus 2, which is negative 138. Okay. So an explicit formula defines the nth term. So it just straight tells you how to find the nth term. Okay? Explain how you can find various terms. Basically replace n in the formula with the number of the term. Replace n in the formula with the number of the term. So it's like x equals, but remember that it's a specific meaning and it's the term number. And then after that, you simply just simplify. Okay, you have to do a lot of this on MathXL, but you'll get the hang of it. Okay, recursive formula uses a previous term, and that previous term is the first term. So notice this is a to the 1. So this is the first term. And that must be given. Or if you're writing this, it must be stated. You cannot do a recursive formula without knowing the first term, because we get the second term built off the first term. So when you look at this formula, a to the first, that's your first term. Okay, and it must be given. We'll put that in parentheses right there. Here's our formula. So a to the n means the current term. So if we were writing this, we would write 5, comma, note that is given. And the current term, which would be the second term, uses the previous term. And that's why it's called recursive. So if we were finding the first 5 terms here, well, we know the first term is 5, which I've written down here. Sorry, you can't see that. We know the first term is 5. So the second term is going to be a to the second. And this a to the n minus 1 means 2 minus 1, which is, of course, the previous term, plus 3. So this is a to the first plus 3, all right? And that is going to be, the first term was given. That's going to be 5 plus 3 equals 8. So the second term here would be 8. All right, the third term is going to use a to the n minus 1, the second term, plus 3, okay? And we just found that as 8 plus 3, so this is then 11. Maybe I'll make all of these equal marks. Put my little arrows. All right, so 11 is the next term. The fourth term, 1, 2, 3, fourth term, right here, slide it in right there, is going to use the third term and add 3 to it. So 11 plus 3, 14. And last but not least, the fifth term, I'll just go over here, is going to use the fourth term plus 3. The fourth term is 14, plus 3 is 17. So big takeaway here, a recursive formula, you have to have the first term given, or if you're writing that formula, which we'll do later on, you have to give the first term in your answer. Okay, so a to the first here is 3. So the second term is going to be 3 times 2. Sorry, I should have put the 2 down first. So 2 times that first, a to the first, plus 1. So 2 times 3 plus 1, which is 7. 6 plus 1 is 7. So the third term will be 2. Look up, grab the previous term, and add 1. 14 plus 1 is 15. The fourth term will be 2 times, look up to the line above, 15 plus 1, that is 30 plus 1, which is 31. And last but not least, the fifth term here will be 2, look to the previous line, 31 plus 1, that is 62, plus 1 is 63. Okay, so if we were to list these, we would say 3, 7, 15, 31, 63. And you could write dot, dot, dot if you were, showing the sequence in general. Okay, so let's go backwards. Okay, let's go backwards here and write a recursive formula for this sequence. Okay, so it said recursive. So the first thing I want to do is write that a to the 1 is equal to, make this statement 2. And then what happens to get to 6? Well, we basically just added 4. 6 to 10, we added 4. 10 to 14, we added 4 to the previous term. So you add 4 to the previous term. And how do we show previous? A to the n minus 1. So the current term, a to the n, will be the previous term, a to the n minus 1, plus 4. All right, so 2 parts always when you write a recursive. Okay, and we're almost done here. So a recursive formula defines the nth term by using the previous term. Okay, and so explain in your own words how you can find various terms. Plug in the previous term for a to the n minus 1, and then simplify. All right, I think that is about it. Okay, so there is 9.1. If you can just kind of, embrace chapter 9, it's kind of a fun chapter because it's brand new, and, maybe if you struggle with factoring or some other algebraic concepts, this can be just like a clean slate for you really to, make a good score on the test and everything. All right, guys, we'll see you in the 9.2 video. Bye.